Okay, this section is on special factoring. The first part is factoring the difference of two squares. And now this is just a formula kind of that we have to go by. A squared minus b squared equals a plus b times a minus b. Okay, when we're talking about the difference of two squares, these problems are always binomials. Okay, we say that they're always binomials, and it must always be a difference. Okay, so difference means subtraction, so you have to look for that in your problem. And it says difference of two squares. Okay, a square is what I would call a term that I can take the square root of evenly. Okay, like 16. Because I know that the square root of 16 is 4. 4 times 4 is 16. Or 25. The square root of 25 is 5. So that would be an example of a perfect square. Also x squared, because x times x is x squared. Okay, if I look at, again, what the formula says, a squared minus b squared equals a plus b times a minus b. If I look at example A, I have x squared minus 16. Okay, if I want to break this down, I notice I have a negative sign. Both of these are perfect squares, so I can break this into two binomials. The square root of x squared is x, so I would have x times x, and the square root of 16 is 4. And now one sign must be positive, one sign must be negative. So this would be my answer, x plus 4 times x minus 4. If I check this by using the FOIL method, x times x would be x squared. X times negative 4 would be negative 4x. 4 times x is 4x. 4 times negative 4 is negative 16. And so what happens is those two middle terms will subtract out, and I end up back with x squared minus 16. Okay, so that's because it is the difference of two squares. Okay, now let's look at B. X squared minus 9. Again, I want to make sure that it is a difference and that I can take the square root of both terms. So the square root of x squared would be x. The square root of 9 would be 3. One sign positive, one sign negative. It does not matter the order as long as you have one of them positive, one of them negative. Okay, let's look at part C. I have 49x squared minus 25. Okay, 49 is a perfect square, and so is 25. So that would be, the square root of 49 is 7x, and the square root of 25 is 5. One sign positive, one sign negative, and that's my answer. Okay, D is y squared minus 64. Again, both of these are perfect squares. So the square root of y squared is y, and the square root of 64 is 8. One is positive, one is negative. Okay, if I look at problem E, 36x squared is a perfect square, and 100y squared is a perfect square. The square root of 36x squared is 6x. The square root of 100y squared would be 10y. One sign positive, one sign negative. So 6x plus 10y times 6x minus 10y. Okay, if I look at F, 9x squared plus 16. 9 is a perfect square. 14 is a perfect square. But this is actually going to be prime because of this plus sign. If we try to work it out, we say the square root of 9 is 3x. The square root of 16 is 4. If I make one positive, one negative, when I check this, that would give me a negative 16, which I do not have in the problem. If I made them both positive, then when I check this, I would have an extra term. I would have 9x squared Then 3x times 12 would be 12x. 4 times 3x would be 12x. 4 times 4 would be 16. And my middle terms would not subtract out. So I would end up with 9x squared plus 24x plus 16, okay, which is not what we started with. So this is why it must be the difference of two squares. This has to be a subtraction sign. Okay, so this one would be prime, or we would say that it cannot be factored, which I believe on your homework problems you type a P or it's either an N for no solution. Okay, one more problem that I want to show you from these would be if I have, let's say, 10x squared minus 40. Well, 10 and 40 are not perfect squares, but let me remind you about that first step that we've been talking about, GCF. There is a greatest common factor. 10 will go into both of these. So first I would need to take out the 10. 10 into 10x squared would be x squared. 10 into negative 40 would be negative 4. And so now I look at what I have in the parentheses, and that is the difference of two squares. So that would be 10 times x plus 2 times x minus 2, because the square root of x squared is x, the square root of 4 is 2, one positive, one negative. But all of this, including the 10, would be in my solution. Okay, so on these problems also, you can have a greatest common factor that could show up. But all of these should be, in the first part of this section, should be just binomials that you're factoring by taking the square root of each term, making sure one sign's positive and one sign is negative.